this is Ruby. We're going to talk about the second part of Chapter 5, which is doing sample problems. So the first thing we're looking at here is how to do a sample problem without having a mathematical equation. So the first thing you would do is to go ahead and make your distribution with your z-scores of 0, 1, 2, 3, -1, -2, and 3. So right there at the bottom, you have your z-scores. Then the next thing you're going to do is you're going to go ahead and label them. So you would label them with 0 as being 50, and then you would go ahead and add one standard deviation. So 50 plus 1 is 58, plus a second standard deviation, which would be 58 plus 8, which is 66, plus another standard deviation, which would be 74. On the negative side, we'd have 50 minus 8, which is 42, then 42 minus 8, which is 34, then 34 minus 8, which is 26. All right, so the first one is going to be finding x equals 54. So I'm going to give you just one moment to go ahead and label your distribution, and then we can take a look at what we have. Okay, so the first thing that you have to do is you have to find an x of 54. If we look at an x of 54, what we would see is that that x of 54 is going to lie between our mean of 50 and our standard deviation of 1. And between those two is a value of 8, right? So we have 50 and we have 58, and we need to find where 54 would land. So it would land right in the middle. And another way that we could do that certainly is we could use our equation. So we could look at, if we looked at 54 minus 50, we'd see that we had 4. So we're halfway between 50 and 54, which really means we're at a 0.5 standard deviation. And if we went ahead and did the rest of the problem, we'd see that it takes us to 0.5. All right, so that's easy enough. Now, if we look at our next value, which is an x of 42, what we see is that 42 is going to lie below. It's going to lie below because that number is less than our mean. And this one's easy to find because this one lands right on -1, because the distance between 42 and 50 is 8, and that's the distance of our standard deviation. So we want to remember that on the positive side, we're always going to be looking at our standard deviations in terms of the value, and each one will have the same value. And on the negative side, we still have a situation with the same value, but what we need to remember is that that value is no longer positive, but that value is negative. All right. So let's go on to the next idea. So the next idea is, what would happen is we have been looking for a z-score, but now instead what we're going to be looking for is not a z-score, but instead we're going to look for the standard deviation. So here what we have is we are given still 3 knowns, because we always have to be given 3 knowns to solve the 4th unknown. So what we're given in this problem is that we have a mean of 65, we have a z of -2, and we have an x of 59, and we need to find the standard deviation. So the first thing we're going to do is we're going to change this m to a mu, because it should be a mu given that we are solving here for population parameters. So for a population with mu of 65 and a score of 59, what corresponds to a z of -2? So we have our equation with our population parameters. We have x minus mu over sigma, which is the standard deviation. All right, so we're going to go ahead and solve for that. So the first thing that we're going to do is replacement. So the x is simply going to become the value that we have, which is 59. So that's going to become 59 minus mu, which is 65. All right, so essentially what we have now is we just have 59 minus 65, and we have that over our standard deviation. And we know that our z has been given to us as being 2. All right, so the next thing we have to do is we have to remove this standard deviation that we have in the denominator. In order to do that, we're going to have to multiply both sides by the standard deviation. So now what we're going to get is a negative 2 standard deviations, and then we're going to take 59 minus 65. We're going to go ahead and do that equation, and we get a negative 6. All right, now we have to get rid of that negative 2 because we need the standard deviation to be alone on the left-hand side. So in order to do that, we're going to go ahead and divide by a negative 2. So now we divide by a negative 2, and that would give us a standard deviation of 3. So just a series of fairly simple mathematical operations that you do, just so that you can remember how to do them. Once again, you're just going to simply substitute and then solve for the unknown that you have. All right, so let's go to the next problem. So the next problem is going to ask us, what is the mean here for the population? And again, we have 3 pieces of information, because as we discussed, we need to always have 3 pieces of information. So it starts off with, we know that we have 1.50 for our z. So we know that we have 1.50 for our z. We also know that in this particular case, we have our score value, which is 33. What we have as an unknown is our mu, and we have a standard deviation of 6. All right, so the first thing that we're going to do then is multiply each side by 6. So that will simply get rid of that denominator. Now what we have is 1.50, and that's going to be multiplied by 6. So that's going to give us essentially a 9. And then we have 9 equals 33 minus mu. Okay, so then what we need to do is we need to get rid of this mu. So what we're going to do is we're going to add the mu to each side. So we're going to go ahead and add that mu to this side. And so now what we have is mu plus 9, and we have 33. So we have mu plus 9, and we have 33. Now to get rid of that 9, we're going to have to subtract the 9 from both sides. So we subtract it from the left side. We also subtract it from the right side. And we end up with mu equals 24. All right, so once again, you just need to keep track of each piece that you're doing. And once again, you just need to make sure that you have 3 pieces of information to solve for the 4th. All right, now, here is another equation for you to write down. So the equation that you have here is for the population. And you can clearly see that in this case, what this equation is giving you is a way to solve for x. So we have x equals mu plus z plus, multiplied by the standard deviation. So once again, we're solving for x, and we have mu plus the z-score times the standard deviation in the population. If this were a sample, we'd still have x, but instead of having mu, we'd have the alphanumeric m, we'd still have z, and we'd have the alphanumeric s. And that would be the equation that would be comparable for the sample. And remember once again that from an arithmetic standpoint, that the population and sample would give you an equal answer. All right, now, so how would we solve for this? Well, again, we'd be in a situation where we'd have 3 knowns. So we have the mu is 60, we have the standard deviation is equal to 5, x is unknown, and z is equal to 2. So now we would simply substitute. So we would go in, and we don't know what x is. We know that our mu is equal to 60. we know that our z-score is equal to -2, and we know that our standard deviation is equal to 5. So we would go ahead and do our mathematics. So we have 60 minus 10, and that equals 50, right? So once again, if we just thought about what our equation was, we had mu, and then we had plus, right? And in this case, we ended up with a negative because we had -2 times a +5, but the equation is mu plus the z-score times the standard deviation. Okay, so I think that's a fairly straightforward equation for you to do. You just need a little practice. All right, now, you should also expect to get a problem like this on the exam. And what this shows is the comparison problem. So what this is asking you is, do you understand the relationship between the mu, the standard deviation, and the z-scores? Okay, so for the first problem, we have a mu of 70, a standard deviation of 3, and we have an x value of 76. So I'm going to give you a couple of moments to go ahead and solve that problem. So we will pause. Okay, so what we have here is essentially we're going to go ahead and we have z equals our score minus our mu over our standard deviation. So in this particular case, we see that our distribution for problem A, all of our scores are relatively close together. And the reason we know this is because we only have a standard deviation of 3, meaning that if we went 1 standard deviation, it would be 73. If we went 2 standard deviations, we would be at 76. And if we went to 3 standard deviations, we'd be at 79 in the positive side. So pretty much you can see that the bulk of the scores are around the mean. So when we go ahead and solve for this, we use our equation of x minus mu over the standard deviation. So we have x equals 76, mu equals 70, standard deviation equals 3. And then we have 76 minus 70 divided by 3. So we have 6 divided by 3 equals 2. So z equals 2. So a score of 76 then is 2 standard deviations above the mean. All right, so that's pretty good. You would want a score that's 2 standard deviations above the mean because that means you're doing quite a bit better than other folks that have taken the same exam. Now, if we look at Class B, we see that those scores are widely distributed. You see that you have scores from 46 all the way to 96, where in Class A, you only have scores from 64 to 76. So what we're going to do here is, because we're standardizing scores, so remember that it doesn't matter what the raw score is, it matters how large the z-score is now. We're going to go ahead and we're going to compute another z-score. So here we have a score, same score of 76, same mu value of 70, and we have a standard deviation of 12. So if we take 76 minus 70 divided by 12, we get 6 divided by 12, which gives us 0.5. So what this now means is you have a z-score of 0.5. So in this case, our score is only going to be 0.5 standard deviations above the mean. So we're not very far away from the mean. So that means that is not a very good score in that distribution. So A is a much better score. And one of the things you want to remember is that whenever we're talking about scores and they're above the mean, you want your z-score to be as far away from the mean as possible if you are in the positive direction. So if your z-score is in the positive direction, you want to be as far away from the mean as possible. If, on the other hand, your z-score was in the negative direction, if it were in the negative direction, you'd want to be as close as possible to the mean. And the reason for this is because if you're further away from the mean in the positive direction, you have a higher score. By the same reasoning, if you're closer to the mean in the negative direction, you have a higher score. All right, now look, and we remember that we have the same score and we have the same mean. What we didn't have was the same standard deviation. So by converting everything to a z-score, one of the main advantages of using the z-score is what I just showed you. There were two different distributions, but we were able to compare that. And we always want to be able to compare distributions that might be measured on different metrics. So even though we had, if we go back and we take that, let us compare the two distributions, because once we convert the distributions, then we have z-scores where the mu is equal to 0 and the standard deviation is equal to 1. All right, now for our learning check, we're going to go ahead and we're going to try this problem. And I'm going to give you a couple minutes to solve this. So last week, Andy had exams in chemistry and in Spanish. On the chemistry exam, the mean was mu of 30 and the standard deviation was 5. And Andy had a score of 45. All right, so there you have 3 knowns, and the unknown you need to solve for is z. And then on the Spanish exam, the mean was 60 with a standard deviation of 6, and Andy had a score of 65. For which class should Andy expect the better grade? So I'm going to give you now a couple of minutes to go ahead and see if you can solve that, and then we'll go back to we'll come back together and we'll solve it together. Okay, so I'll give you a couple minutes now. Okay, so let's go ahead and try to solve this now together. So for chemistry, we know that Andy had a score of 45. There was a mean of 35 and a standard deviation of 5. And right here on the right-hand side, I've once again written the equation, which I suggest you do, just as a matter of principle, and also just as a matter of organizing yourself. All right, so we know that her score was 45 and the mean was 30. So right away, you should think this means she did better than the mean. So far we're happy because we're better than the mean. Now let's see how far away we are from the mean. Well, our standard deviation was 5. So if we take 15 divided by 5, we get a score of 3. So z equals 3. So a score of 45 is 3 standard deviations above the mean. So that means that we're quite far out from the mean. We're 3 standard deviations above the mean. Now, in the Spanish class, we have a score of 65. Andy has a score of 65, and she has a mean of 60, and she has a standard deviation of 6. All right. So again, we have a situation where Andy has done better than the mean. So that is great. So, but how far away is she from the mean? And that's always going to be our question. So we have 5 divided by 6, which is 0.83. So her score of 65 is 0.83 standard deviations above the mean. Now, so because of this, we know that she didn't do quite as well in terms of the her distance from the mean in Spanish as she did in chemistry. So we should suspect that she should have a better score in chemistry, which is answer A, because she is further away from the mean with in the positive direction with a z-score of 3 than a c-score of 0.83. Remember that we talked about this, that when you're in the positive direction with your z-score, you always want to be as far away as possible from the mean. So a 3 would be much better than a 0.83. Now, on the other hand, if this had been negative numbers, and let's say you had a negative 3 and a negative 3 and a negative 0.83, then it would be better for you to have a negative 0.83 because that would mean that you were closer to the mean than the score of negative 3. Okay, so that's the end of our problems for chapter 5, and I hope you will review your mini assignment, and I hope this has been helpful, and I will be back with chapter 6. All right, take care. Bye-bye.